Hi, I'm Jeff Wittich, Head of Products at Ampere Computing. We're excited to announce the world's first cloud-native processor, the Ampere Altra processor. This is the first CPU that was designed from the ground up for the unique needs of the modern cloud. When you look back over the last 10 or 15 years, the needs of the cloud have dramatically diverged from the needs of traditional enterprise IT. A number of changes have occurred. The software ecosystem has changed as developers have moved towards cloud-native applications and the shift towards containers and microservices. There's been a large growth in the edge, which necessitates distributed computing across your entire infrastructure, which also demands increases in power efficiency, as well as additional demands to increase the density of compute for large hyperscalers. Also, with the emergence and the growth in AI and machine learning, this has increased the need for compute capabilities across the entire infrastructure. And lastly, as cloud service providers have optimized their infrastructures, they've moved to more and more customized architectures, especially those that are heterogeneous. They're starting to deploy GPUs for AI training, they're using smart NICs for network offload, and increasingly, they're looking at using non-x86 CPUs in their infrastructure as well. Looking back over the last 10 or 12 years, the current solutions do not meet the needs for the cloud. From 2008 to 2013, x86 processors were able to increase performance by 60% annually, and also improve performance per watt at the same rate. However, since 2013, the rate of innovation has slowed down dramatically. Not only has the rate of improvement in performance slowed, but the performance per watt increases have also similarly slowed as power is needed in order to increase performance year after year. And power consumption is more than just a concern around OpEx and density. It's a global issue as well. Today, data centers consume about 3% of the worldwide energy. However, experts predict that could grow to as much as 11% over the next decade. Over the last 5 or 10 years, that 3% number has been able to be maintained because of innovations in data center efficiency as PUE has decreased. However, all of the easy things have been done. We need new innovation in order to continue to maintain the current levels of energy consumption. And when we look at greenhouse gas emissions, the airline industry is currently regarded as a major offender. However, data centers today actually emit as much greenhouse gas each year as the airline industry. We need power-efficient processors in order to continue to improve those numbers over time. At Ampere, when we look at the needs of the modern cloud, we think of 3 key areas. 1, the cloud needs predictable high performance. 2, it needs scalability across the entire platform, from cores to I/O to memory. And it needs power efficiency and density. At Ampere, we've designed the Ampere Altra processor to meet those 3 needs in a unique way specialized for the cloud. Our Ampere Altra processor has 80 cores to deliver high performance, exceeding any other CPU in the market. It's scalable across I/O and across memory, with more I/O bandwidth and memory bandwidth than any other processor in the server market. And it's the most power-efficient server processor in the market as well. From a processor perspective, the Ampere Altra processor has 80 64-bit ARM cores. Each core is able to run at a sustained 3 gigahertz. That's 3 gigahertz across all cores, across a wide variety of cloud workloads. Again, it's important that we deliver consistent performance regardless of how many users are on the platform and regardless of what workloads are actually running. In addition to the consistent turbo performance that the Ampere Altra processor provides, we've also designed the cores to be single-threaded in order to provide better performance and security isolation. The 80 cores are connected by a high-bandwidth mesh interconnect on a monolithic die. We specifically chose to design this generation of processors with a monolithic die in order to avoid bottlenecks that occur in current chiplet architectures. We've also emphasized a very large cache, especially our L1 and our L2 private caches. We have a 64K instruction and data L1 cache and 1 full meg of private cache in the L2. Because these caches are private, you don't have to worry about resource contention from various cores. Additionally, we've chosen to optimize our L1 and our L2 caches, which are closer to the core, providing higher performance and lower latency. The Ampere Altra processor also has one single 32 meg shared system level cache as well. The Ampere Altra processor has two 128-bit SIMD units for vector and floating point performance. And since inference performance is becoming increasingly important as AI inference is being done across a wide variety of servers in the infrastructure, we've also introduced int8 and FP16 support for those who are using those numerical formats for inference performance improvement. Going back to the single-threaded approach, we've specifically designed our cores to avoid noisy neighbor effects. This can show up in either performance or in security. By having single-threaded cores where no threads are sharing the execution engine, the registers, or the L1 or the L2 cache, we avoid resource contention. We also are able to provide better security isolation by reducing the attack surface. This has become a particularly problematic issue over the last couple of years with some of the side channel attacks that have become prevalent in the industry. In addition to the resource isolation that single-threaded cores provide, single-threaded cores also provide more consistent execution of instructions. In the case of a multi-threaded core, 2 threads are executing at any given time. These threads typically belong to 2 different users on a single system. As thread 1 executes, eventually it stalls, either because of a cache miss or a branch mispredict. Thread 2 then begins executing. Thread 1 doesn't get control again until thread 2 stalls. This results in a larger number of total clock cycles required in order to execute user 1's instructions. In the case of a single-threaded core, like the Ampere Altra processor, thread 1 is able to finish execution in a more consistent and predictable number of clock cycles. The Ampere Altra processor also has an optimized memory subsystem. The processor supports 8 memory channels of DDR4 memory at 3200 megahertz. It also supports 2 DIMMs per channel, also at that maximum 3200 megahertz speed. This allows us to provide the maximum possible memory bandwidth to feed the 80 cores in our processor. We also support a total of 4 terabytes of memory in a single socket system or 8 terabytes of memory in a dual socket system. Not only does the Ampere Altra processor have high memory bandwidth, but we also deliver high I/O bandwidth and fan-out. The Ampere Altra processor supports 128 PCIe Gen 4 lanes in a 1-socket platform and 192 PCIe Gen 4 lanes in a 2-socket platform. This is more I/O bandwidth and connectivity than any other server platform in the market. Not only do we support high I/O bandwidth and fan-out, but our by16 controller is also bifurcatable down to by2. This means that not only do you have the option of connecting a lot of high bandwidth GPUs via our by16 controllers, but you could also connect a large number of NVMe devices in by2 mode for extremely high fan-out. Another thing that's unique about the Ampere Altra processor is that across our SKU stack, we're supporting the full range of I/O, memory, and features across all of the CPUs that we produce. We'll support the full memory capacity, the full memory bandwidth, the full I/O bandwidth, as well as all of the features like our RAS capabilities. Another thing that's unique about the Ampere Altra processor is that we support C6 connectivity at the platform level for the attach of cache-coherent accelerators or storage class memory. Our philosophy when it comes to I/O has been to embrace a multitude of flexible I/O options, especially those that rely on open standards like C6. From a manageability perspective, the Ampere Altra processor supports ARM SBSA Level 4 So customers know that when they deploy our platforms, they'll work seamlessly with their existing infrastructure. It also has the full range of performance and thermal management features that you would expect out of a server-class processor. The Ampere Altra processor also has a full range of RAS features. Now that I've told you about the Ampere Altra processor and the way that we've designed it for the needs of the modern cloud, now it's time to look at the actual data to prove how well it performs. The Ampere Altra processor and its 80 cores outperform the 64-core AMD EPYC processor and the 28-core Intel Xeon processor, providing leadership performance across all of the performance-sensitive workloads in the cloud, whether that's AI inference, transcode, or database. When we take power efficiency into account, the lead extends even further. The Ampere Altra processor leads the AMD EPYC processor by 14%, and the Intel Xeon processor by over 2x. This provides not only the scalability in order to deploy the Ampere Altra processor out at the edge, but it also provides the right level of performance and power for sensitive applications like front-end web and cloud gaming. Another key metric that cloud service providers look at when they're assessing the scalability and density of solutions is the number of cores that they can deploy per rack. At some point, they run into a rack-level power limit, which constrains their ability to continue to deploy more and more cores. And in the cloud, cores mean more users, more services, and more revenue. Because the Ampere Altra processor has the industry's lowest power per core of any data center processor, we're able to deliver more cores per rack than any other solution. The Ampere Altra processor delivers over 3,500 cores per rack. That's 38% more cores per rack than the AMD EPYC processor, and 173% more cores than the Intel Xeon processor. The Ampere Altra processor is the leading solution for maximum density in your data center. Total cost of ownership is also an important consideration for cloud service providers. Once again, the Ampere Altra processor leads both Intel and AMD. The Ampere Altra processor is able to provide 41% more performance per TCO than the AMD EPYC processor, and 63% more performance per TCO than the Intel Xeon processor. This is even after the recent price cuts with the Cascade Lake refresh. What's really exciting is that the Ampere Altra processor is sampling now. We've sent the Ampere Altra processor in both our 2-socket Mount Jade platform available from WeWin and our 1-socket Mount Snow platform available from Gigabyte to some of the world's largest cloud service providers. In fact, both Microsoft and Oracle are testing the Ampere Altra processor today on their own workloads. At Ampere, we will continue to deliver the world's highest performance, most scalable, and most power-efficient processors uniquely designed for the needs of the modern cloud.